Guys, we're continuing with the paper that was written on the 9th of June in Gauteng, June 2023, mathematics. Right, so we're doing question 4 right now, right? So in question 4, we're given f of x is equal to x squared minus 2x minus 3, which is a parabola, and g of x, which is x minus 5, which is a straight line graph, right? So 4.1.1 says, show that the turning point of f is 1 and negative 4. So let's quickly write down f here, right? So we have f of x. Let me just use a color that's more visible. Let's go. F of x is equals to what? X squared minus 2x minus 3. So now they say that show that the turning point, right, is that. So yeah, a lot of ways to do that. So let's try one that we did in grade 11, right? Let's try x is equals to minus b over 2a, right? So this x minus b is equal to minus b over 2a is a formula that we use to find the x's of symmetry, right? And by that we mean the x value of our turning point. So let's find the x value of our turning point and then replace it back into the formula to find the corresponding y value. So our b is negative 2, so it's x is equals to minus negative 2 all over 2 times a. In this case, it's 1. So this is going to give us positive 2 over positive 2, in which we get 1 indeed, right? So now let's find our corresponding y value, f of 1. Let's go and replace 1 wherever x is equals to 1 squared minus 2 into 1 minus 3, right? So we understand that 1 squared is the same thing as 1. 1 minus 2 is negative 1, and negative 1 minus 3 is indeed negative 4. So we can therefore clarify that the TP, tapelo, right, turning point is 1 and negative 4. Right, so let's continue. Right, let's continue. So we're doing 4.1.2, which asks us to determine the coordinates of the x and y intercept of the graph of f, right? So we understand. Let's write our graph of f again. So let me just label this. This is 4.1.1. So now we're doing 4.1.2, right? F of x is still equal to x squared minus 2x minus 3, right? So now we understand that when we are finding the x intercepts, right, we let y be equal to 0, right? So 0 is equal to x squared minus 2x minus 3, right? So now let's resume. 0 is equal to, let's factorize this, right? So we're going to find the factors of negative 3, right, that give us the middle term, which is negative 3 and positive 1, because we understand that their product gives us that and their sum gives us that, right? And, right, let's resume. Then we're going to have x minus 3 and x plus 1. And then therefore x is equals to, I just want to write them in ascending order, negative 1 or x is equal to 3. So those are our two x-intercepts. So now the coordinates are negative 1 and 0, because we understand that where the graph cuts the x-axis, the y value is 0. So we're going to have here 3 and 0. So right, let's move to the next question, which asks us to determine the point of intersection of the graphs of f and g. So the graph of f and g, right? Let's understand something, right? So where two graphs meet, they are equal at that specific point, right? So now we need to determine the coordinates, the points of intersection between the two graphs. So we need to equate these two graphs, because we understand that at the point of intersection, at that specific point, they're not always equal, but at that specific point, they share an x value and a y value, right? So let's go. So we understand for the point of intersection, we need to say f of x is equal to g of x, right? And our f of x is x, let's go, x squared minus 2x minus 3 has to be equal to x minus 5, I believe. x minus 5 raised, right? So now I want to find the x values where they are equal, and then to find the coordinates, we just take the x value or values that we find and replace into any one of these formulas, because we understand that at that point, not only are their x values the same, their y values as well are also the same as well, right? So let's go again. Let's bring everything to the left, minus 2x. So minus 2x minus x is going to give us minus 3x, and then minus 3 plus 5 is going to give us positive 2. And then that is equal to 0. Then we factorize here. So we need to find the factors of 2 that give us the middle term, right? So we know that 2 can also be written as negative 2 times negative 1, right? So we can replace that, minus 2 here, x minus 1. So therefore, x is equal to 1 or x is equal to 2. So now let's find the corresponding y values at those at the x points of intersection, right? So let's go. I'm just going to use the G graph. Y is equal to what? X minus 5. So therefore y is equal to 1 minus 5. So they intersect at y is equal to minus 4, right? And then they also intersect right where y is equal to x minus 5. Therefore, y is equal to 2 minus 5, where y is equal to negative 3, right? So we got on the points of intersection. So, yeah. So now let's just write that in point form. By that I mean the coordinate form, right? So 1 and negative 4. We have 2 and negative 3. Right, let's resume. So I'm just going to move this down. Let's resume, right? So then the next question asks us to sketch the graphs of f and g on the same set of x's. And we should clearly label the turning point where the graphs intersect, as well as the x and y intercepts of both graphs. So we sorted with the x-intercept, the x and y intercepts of the graph of f, right? Though we didn't find the y-intercept, but we understand that the y-intercept is, of course, negative 3, right? So let's just go fill that in at 4.1.2. We understand the y-intercept, y-int, is where y is equals to negative 3, right? So therefore, our coordinate is going to be 0 and negative 3. Sorry about that. So let's resume. This was 4.1.3. And now we're doing 4.1.4, right? And yeah, so we sorted with the x and y intercepts of f. And by having this formula already, we already have the y-intercept of this graph. And therefore, we can find the x-intercept and then sketch it, right? So we've sorted. Let's go see what we can do. So 4.1.4, right? So here in this case, let's just find the x-intercept of g of x, right? You understand that at x-intercept, we let y equal to 0, right? So 0 is equal to x minus 5, which means that x is equal to 5 at the point of intersect, at the y-axis, at the x-axis, right? So we have a coordinate 5 and 0, right? So now let's just draw our graph briefly. Right, so I'm just going to draw my axes here with the x-axis and the y-axis like that, right? So I just want to mark the important points, right? So we can see we have where x is 1, where x is 2. So I just want to just clearly label those. Let's say this is 1 and this is 2 here. And we also have where x is negative 1, right? So I'm just looking at the x values and where x is 3, right? So we know that we want to have something where x is 3 and where x is negative 1, as well as where x is 5, right? Which is the x-intercept of the straight line graph. So yeah, let's try and draw it into scale as possible. So yeah, I think those points are not too bad. Let's go to the y values. We have a scenario where y is equal to negative 3. So I'm just labeling. So this is 1, 2. Let this be negative 3 here. And we're also where y is equal to negative 4. Remember, that was the turning point, negative 4, right? And what else do we have? Any other y value that we have? So we can just label only the points that are important, right, for us. So now let's just go plot. Let's start with the straight line. Let's start with the parabola, right? So with the parabola, we understand that we have our x-intercepts at -1 and 3, as well as the turning point at 1 and -4. So let's plot that one. Right? So we have a turning point at 1 and -4. So that's somewhere there. And we also have an x-intercept here and another x-intercept there, right? So we also understand that where x is 0, its turning point, its y-intercept is -3, right? So let's just go plot that one there. So we have that. So we have our graph going through there, into there, and all the way through there, right? So this can be fixed just like that. So let me just redraw it one. So we can have something like that. Something like that, right? So yeah, we can have something like that. And then, yeah, we sorted, right? So that's our graph of f, right? And now let's draw our straight line graph, because we understand that as well, we also have a point here, right? Which is 5, a y value of 5, -5, right? Which is the y-intercept of our graph of g, right? Because we understand that this represents the y-intercept, because if we can simply replace 0 with, if we can simply replace x with 0, we'd get a y value of -5. So that's our y-intercept. So now let's go draw this with a different color. Let's try green. Right, so we understand that we have a point there that cuts through that, and also it cuts at +5, right? But also we have points of intersections, right? So our points of intersections are what? -1 and 4. 1 and -4, as well as 2 and -3, right? So let's go 2 and -3 is somewhere there, and 1. Yes, okay, 1 and -4 is exactly at the turning point, right? So that's there. So it cuts this graph at 2 points. So let's just quickly fix this one and make it more curvy there, so that we can accommodate our straight line graph. Right, so we have that. So let's draw a straight line graph right away. We understand that it goes through here. It passes through that, and it cuts through the x-axis at 5 and goes all the way there. Right, so we are done drawing our graph. So now we can just label our points. So here we have 5 and 0. Here we have what? We have +3 and 0. And then we have here -1 and 0. And here we have 0 and -3. And then here at our turning point, as well as our point of intersection, we have 1 and -4. And here we have 2 and -3, right? So that's what we have there. So we've sketched our graph. So yeah, let's go to the next question, right? So the next question asks us to determine the values of x, where the graph of f of x is greater than 0, right? So now we can use the graph, right, to determine the values where the graph of f of x is greater than or equal to 0, I mean to say, right? So if it is like maybe challenging to interpret the graph, just write it down and solve it as an inequality, right? So let's just do that, just to as a way to confirm our answer. So there we have what? Our f of x is what? X squared minus 2x minus 3, right? Greater than or equal to 0. So now let's find the x values. So we understand that we have x minus 3 and x plus 1, right? So our critical values are -1 and +3, right? So if we were to sketch our graph roughly like that, we understand that this would be -1 and this would be 3. But when they say where the graph is greater than 0. So if we look at this graph is only greater than 0 where it is to that side of -1 and to that side of +3, because we understand that in the space between here, right, the y value of the graph is below the x-axis, meaning it is negative, but we want where it is positive or equal to 0, right? So let's go and look at our graph and try look at it using our graph, right? So the same thing. We can see that our graph only exists, right, above the x-axis to that side of -1, right? Because even if we can let me just use a different color just to show our signs, right? So we understand that here it's positive, here it's positive, positive, positive. But as soon as it goes below the x-axis, we're talking about the y values, right? Negative, 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 negative. And then when we get here, it becomes positive again, right? But at that point here, it's 0. And at that point there, it's also 0, right? So let's go. The last question. 4.1.5, I believe it's where x is less than or equal to -1, or where x is greater than or equal to +2. And then that's where we have it. So we're done with 4.1.5. Let's go to 4.2, right? So let me just stop here, and then we'll do this in the next video.